Hello everyone, Principal Sylvester here. I'm going to start working on part 2 of our exponents video. I'm going to review the challenge from last video, and then this will put us on par with um, any other problems that we have to simplify using PEMDAS. All right, so let me start sharing my screen. All right, so this video is going to focus again on part 2 of exponents. Don't forget that we need our base and our exponents before we can move forward. Now, a quick recap of what we did on the last video. So far, we learned the product rule of exponents, which means when the base is the same, we add the exponents. All right, pay close attention to the signs because we could have positive and negative exponents. The other rule that we learned was the negative exponent rule, which means that whenever you have a negative exponent, that means that we have to do the reciprocal of that value. That means we have to divide 1 by that value. Once you do the reciprocal, you get rid of the negative exponent and it becomes positive. So if I have x raised to the negative 8 power, that means I have to divide 1 by that value and the negative exponents drops. And then we have the quotient rule of exponents, which means that when you are dividing the same base, you will have to subtract the exponents. All right. And last but not least, we cover the zero exponent rule, which means that any value except for 0, so any non-zero value raised to the 0 power will always equal to 1. All right, so keep that in mind. That's a recap from last video. And let's continue with the challenge from last video. All right, and remember, before we could finalize this problem, let's simplify the numerators and the denominator first. All right, it's always convenient when we simplify the numerator and the denominator. If you take a look, you start with the numerator. You have to find out if you have any bases that are the same. Now remember, all numbers, we could do math operations to all numbers. So I'll pull out the number 4 and number 6 in the numerator. So I have 4 times 6. Then we have x on both sides. So you know that that is the same base. So you're going to add the exponents. You have positive 5 and negative 5. And then you have y, which you have a positive 3 and a negative 3. So in the numerator, we are multiplying across. Therefore, when you multiply the same base, you add the exponents. Followed by the denominator. If you look at the denominator, we do not have any values that are the same. Therefore, it is already in the simplest form. All right, so next step, we're just going to do the operations. We know that 6 times 4 or 4 times 6 is 24. We know x raised to the 5 plus negative 5. We know that when we add a negative, we are basically subtracting. So it's like 5 minus 5 gives you 0. We also know that we have y raised to the 3 plus negative 5. Again, when you are adding a negative, you are adding a depth. So you are basically subtracting. So you have 3 minus 5, which gives us negative 2. All right. In the denominator, we have 2 to the third power, which we know is 2 times 2 times 2, which is 2 times 2 is 4, and 2 times 4 is 8, which gives us 8. And then we had x to the second power and y to the negative 4. If you looked at this, we already simplified the numerator. We already simplified the denominator. So we can move on and simplify, apply the quotient rule. All right. So now when we move on, I take the numbers, 24 divided by 8. Then I have x to the 0 minus x raised to the 0 power minus 2, because again, when you are dividing and you have the same base, you subtract the exponents. Therefore, you have 0 minus 2. And now be mindful of the y value because you have a negative in the denominator. You have a negative exponent in the denominator. Therefore, when I follow my quotient rule, I have the same base. So y raised to the negative 2 minus negative 4. Remember, when you are taking away a debt, that is something positive. Therefore, when you subtract a negative, you are basically adding. So negative 2 minus negative 4 becomes negative 2 plus 4. All right. We know that 24 divided by 8 gives me 3. X to the 0 minus 2. X raised to the 0 minus 2. We know 0 minus 2 is negative 2. And then we have y raised to the negative 2 plus 4. We know that 4 is the larger value. So, and you have a negative number. So I'm going to subtract and keep the sign of the larger number. Therefore, I get raised to the second power. Now, this right here is now my final answer because you cannot have a negative exponent as your final answer. We already know that in order to get rid of the negative exponent, we have to do the reciprocal, which is 1 over x squared. So that brings x to the denominator. So our final answer becomes 3 times y squared divided by x to the second power. All right. If you need to review this again, just pause, go back, and follow the steps one by one so you could end up with the same answer. All right, remember, every time we have complex operations in the numerator and the denominator, it's always best to simplify them before we move forward. That is going to make your life easier. All right. All right. So we are going to learn two new rules today. The first one is power of power rule. Actually, we're going to learn three. But the first one is going to be power of power rule. That means that whenever you have a base that is raised to a power, and then that gets raised to another power, you're basically doing a power of power. So an example would be 2 raised to the third power, and then you raise that value to the second power. The parenthesis is here to let us know that anything inside the parentheses is going to be raised to the second power. When this happens, you start working with the outermost exponent. So in this case, I know that 2 to the third power raised to the second power is the same thing as saying whatever is inside of this parenthesis is being multiplied by itself twice. So I have 2 to the third power multiplied by 2 to the third power. I have the same base. So we know that the product rule tells us if I have the same base, I have to add the exponents. So I end up with 2 to the sixth power. All right. This worked out because we have simple numbers. However, when you start dealing with larger numbers, you have to make sure that you apply the correct way of doing power of power. In this case, when this happens, we basically multiply the exponents. You multiply the exponent on the outside with the exponents of the base on the inside. So 2 to the third power raised to the second power is the same thing as saying 2 raised to the third power times 2. So we know that 3 times 2 is 6. So my final answer is 2 to the sixth power. All right. So again, when you're applying the power of power rule, you have to make sure that you multiply the outer exponent with the inner exponent. All right. So be mindful if we have multiple values inside of that parentheses. The next rule is a power of a product rule. All right. That means that inside of the parentheses, instead of having just one value, you have a product inside of that parentheses. You have an operation. It could be between two numbers. It could be between a number and a variable. All right. So if you take a look at this example, I have a 4 multiplied by 8 to the third power. My coefficient right here is 4. My variable is the letter A, and it's raised to the third power. All of this is within a parentheses, and that has to be raised to the second power. Doing this the long way, we could see that I multiply the inside of the parenthesis by itself twice. We see that the two numbers, 4 times 4, you multiply them with each other. And then you have AQ times AQ. All right, remember, this is the long way, but it shows us how we get to the final answer. Now, so we have the same base at the exponents. So 4 times 4, we know that it's like saying 4 over 1 plus 1. Then we have 8 to the third times 8 to the third, same base. So we have 8 to the third plus 3. So if we simplify this, we end up with 4 to the second power and 8 to the sixth power. And we know to simplify this, we know what 4 times 4 is. And that gives us 16 times 8 to the sixth power. However, we want to make sure that we use the power of power rule. All right, so going back, we know that if I have the 2 on the outside, we know that 4 is a base number, and we know the exponent is a 1. So now I'm going to distribute the 2 to the exponent in the 4, and I'm going to distribute the 2 to the exponent in the A. All right, I'm going to show you another example on this in a minute, but I just wanted you to be clear to understand that the power of power applies when you have a product inside of the parentheses. All right, before we continue, I want you to understand something that we're going to start using as we start incorporating more variables, especially when we start using X. All right, we have to transition away from using the multiplication symbol that looks like an X. All right, in order to avoid confusion, we are going to transition to using the multiplication dot or middle dot or dot operator, whatever name you are familiar with. That is the dot that goes between the two values to signify that you are multiplying. All right, so now going back to the problem that we had before, we know that 4 times 8 to the third power, we know that we could distribute the exponent. We could multiply the outside exponents with each of the exponents that is inside of the parentheses. We know that the number 4 has an exponent. We know that the variable A has an exponent. So you're going to multiply 2 times 1, which is the exponent of number 4, and then 2 times 3, which is the exponent that we see in A. And we know that 2 times 1 is 2. We know that 3 times 2 is 6. So our final answer is 4 squared times 8 to the sixth power. This is a small enough number that we could actually do the product. And we have 4 times 4, which gives us 16. So our final answer is 16a. 8 to the sixth power. All right. So again, you have to make sure you take your time and you follow the rules accordingly. All right. Pause the video and take a look at these 3 examples. Okay. All right. We're back. All right, so we are going to tackle the first video. You notice that you have 6 raised to the second power multiplied by a to the sixth power. I'm going to advise you that there's no need to do this 6 to the second power. You don't want to do 6 times 6 because now you have an exponent on the outside, so it's going to make that coefficient more complicated. All right, so what I'm going to do is I'm going to follow my power of product rule, which is I'm going to distribute that 5 to each of the exponents inside of the parentheses. All right. So I'm going to say 2 times 5, and I'm going to say 6 times 5. Don't forget your bases. Please do not mix the bases. Keep the bases accordingly how you see it. So we have 2 times 5 is 10. So I know that I have my base is 6. So 6 to the 10th power. And then A, you have 6 times 5, which is 30. So you have A to the 30th power. I do not want you guys to solve what 6 to the 10th power is. We do not need that large number here. Leave it as a base with an exponent. All right. Number 2, same thing. If I have multiple values inside of the parentheses, each of those values get to be multiplied by the exponent. You have to distribute the exponent to each individual value. We know that the 9 has a second power. We know that the letter A, the variable A, has a sixth power. And then remember, when you do not see the power, there's always a power of 1. So now I could distribute the 7. I have 2 times 7, 6 times 7, and 1 times 7. So that drops the parentheses, and I could do my operations. 2 times 7 is 14. So I have 9 to the 14th power. 6 times 7 is 42. So I have 8 to the 42nd power. And 1 times 7 is 7. So I have B to the 7th power. All right. So again, make sure that every single value inside of that parentheses, you are distributing the exponents to each of those exponents. That only applies when you are multiplying inside of the parentheses. Please do not think that this applies when you are adding inside of the parentheses. It doesn't work that way. All right. That's why the reason this is called the power of a product, because product goes with multiplication. So keep that in mind. And last but not least, remember, this one has a coefficient outside of the parentheses. I don't want you to get tricked. This 2 to the second power is not inside of the parentheses. You are only going to distribute the 4 to the values inside of the parentheses. So I'm going to distribute the 4 to the third power, the 4 times -1, and then the 4 times 2. Once I distribute this, the outside exponent disappears. So I end up with 2 to the 3 times 4, A to the -1 times 4, and B to the 2 times 4. All right, if I keep simplifying, I have 2 to the 12, A to the -4th power, and B to the 8th power. Now I see that I still have a 2 to the second power on the outside, and I have a 2 to the second power on the inside of my parentheses. We know that this is a coefficient, which implies that we have to multiply these two values. And we know that whenever we have the same base, we add the exponents. So I end up with 2 raised to the second power plus 12. Everything else stays the same. So you end up with 2 to the 14th power times A to the -4 times B to the 8th power. Now remember, this cannot be our final answer because it has a negative exponent. We have to simplify this one step further. Remember, to get rid of the negative exponent, we do the reciprocal, which is 1 divided by A to the 4th power. And that is why A to the 4th power ends up in the denominator, because that's the only way that we cancel the negative exponent. All right, so my final answer is 2 to the 14th power times B to the 8th power divided by A to the 4th power. All right, good job. All right, the other rule that we have to look at, this is going to be our final rule for this video, is the power of a quotient rule. All right, so basically this is very similar to a power of a product. All right, the power of a quotient is basically you are doing the same thing you did previously, but you have to do it to the numerator, all the values in the numerator, and you have to do it to all the values in the denominator. All right, so if you look at this example, we have 2 to the 3rd power times B to the 5th power divided by A to the 4th power. All of that is part of my parentheses, and you have an outside exponent of 3. That means that I have to distribute 3 to every single one of these exponents inside of the parentheses, regardless if you are multiplying or dividing. So when I multiply 3 times 3, I will multiply 5 times 3, and I will also multiply 4 times 3. All right, so we know that you have 2 raised to the 3 times 3 power, which gives us 2 to the 9th power. We have B raised to the 5 times 3 power, which gives us B to the 15th power. And then we have A to the 4 times 3, raised to the 4 times 3, which gives us A to the 12th. All right, make sure that you simplify as much as possible before dealing with the external exponent. In this case, this is already in the simplest form, but if we had other mixed operations in here, our goal is always to simplify first before we deal with the outside or the outermost exponent. All right, so those are my final rules. I have my product, my power of a product. I have my power of a power, and then I have my power, sorry, my power of a quotient. All right, practice these two, these three problems. All right, pause the video, take a minute, practice them out. All right, we're back. Now remember, you could also have a negative. If you look at the first example, you could have a negative value on the outside as well. All right, but you still follow the rules that we learned. Now remember, the first tip that we gave you was to always simplify whatever's inside of the parentheses first, if possible. So in this case, I have 3 cubed and I have 9 to the second power. If you are not familiar with your numbers, if you cannot just identify any patterns, write everything down. All right. 3 to the third power, we know it's saying 3 times 3 times 3. 9 to the second power, we know it's saying 9 times 9. All right. I noticed that 3 times 3 is 9. So it's like saying 9 times 3. And then I have in the denominator 9 times 9. So this is going to help me out because I'm going to cancel out one of the 9s. So I end up with 3 over 9 raised to the negative second power. I could take this a step further because I know that 3 over 9 could be simplified and it becomes 1/3. All right. Now I simplify whatever's inside of the parentheses. Now I could deal with the external exponent. So I'm going to distribute the external exponent again. Each number has a 1 as the exponent, so -2 times 1. And then here, my third base, my base of 3, I have 1 times -2. So I end up with -2 and 3 raised to the -2. And we know that in order to get rid of a negative exponent, we do the reciprocal, which is 1 divided by this value. 1 divided by 1/3. I'm following my rule. When you divide by a fraction, don't forget, keep, change, flip. So I end up with 3 to the second power over 1 squared, which equals to 3 times 3 over 1 times 1, which equals to 9. All right, so take it step by step. All right, let's look at the second example. You notice right here you have, again, we are going to try to simplify as much as possible. In the numerator, I cannot simplify any further. In the denominator, I cannot simplify any further. So now I'm going to try to do the quotient. I have 4 squared and I have 2 to the third power. I know that 4 squared is 16. I know that 2 to the third power is 8. I have a to the 1 power in the numerator. I have a to the 1 power in the denominator. Then I have b to the 4th power in the numerator, and I have b to the 2nd power in the denominator. Remember that I could do my math operations, and I could follow my quotient rule, which is if I have the same base, I will subtract the exponents. So I know that 16 divided by 8 gives me 2. A to the 1 divided by a to the 1 is a to the 1 minus 1. And b to the 4 divided by b to the second is b to the 4 minus 2. I have not touched the outside exponents yet. I have to simplify the inside first before I move on. So I have 2. I know that a to the 1 minus 1 is a to the 0. And we know that b to the 4 minus 2 is b to the 2, to the second power. And we know that a to the 0 is equal to 1. So we have 2 times 1 times b to the second power. This right here is in the simplest form inside of the parentheses. Now I could distribute my exponent to each of the values here. We know that the 2 is raised to the 1 power, so 5 times 1. We know that you have b to the second power, so I have 2 times 5. You do the operation, you have 2 to the 5th power and b to the 10th power. This is my final answer. All right, so make sure that you simplify first before you do anything else. That is going to help you in the long run in any problems that you're dealing with. You always want to simplify first. All right, the next one. All right, you have negative exponents here. You also have b in the numerator and b in the denominator. That is okay. I'm not going to deal with the exponents, with the negative exponents right now. I'm going to simplify my numerator, simplify my denominator, and then I will simplify my quotient. The only base that is the same is b, so I could do the quotient rule saying b of 4 minus 2. And then I'd say I have 2 to the negative second power, b to the second, a to the negative third. This is in the simplest form, so now I'm going to distribute my 3 to each exponent that I have here. So I have -2 times 3, I have 2 times 3, I have -1 times 3. I have, again, I will do the operations. -2 times 3 gives me -6. 2 times 3 gives me 6. -1 times 3 gives me -3. All right, again, we have negative exponents. I want to get rid of the negative exponents by doing the reciprocal, which is 1 divided by this fraction. All right. So once you divide by the fraction, the the negative exponents disappear. So don't forget, keep, change, flip. You end up with a to the third, 2 to the 6. So my final answer is a to the third times b to the 6 divided by 2 to the 6 power. Okay, I don't have to simplify 2 to the 6 power. That's irrelevant right now. We're going to keep it as an exponent. All right, this is your challenge for next video. Again, we have multiple values in the numerator, multiple values in the denominator. You're doing a product inside the parentheses. Then you have everything raised to the third power. All right, good luck. Make sure that you log in and you try your best. All right, if you have any questions, please put it in the chat. Or if you are one of my students, don't hesitate to reach out when you see me and ask. All right, our goal is to make sure that you have a strong foundation so we could build from it. All right. Thank you. Thank you. Thank you. Have a great day. I will see you around. Bye, everybody.